So we are being given the quadratic function in factored form, which allows us to find the x-intercepts a lot quicker. So we'll sort of work backwards. So if we have x minus 1 and x minus 5, we know that their zeros are going to be the opposite, right? So 1, 0, and 5, 0. But for the rest of this, we're going to need to put this into standard form. So we're going to use the box method to multiply. So we have x negative 1, x negative 5, x squared negative 5x, negative x, and positive 5, which becomes x squared minus 6x plus 5. So now we can figure out the rest of the key features. So the y-intercept is always the c value. In this case, our c value is 5, right? So we know that the y-intercept is going to be 0, 5. And then we're going to find the axis of symmetry and the vertex. So to find the axis of symmetry, we're going to use negative b over 2a. So our b is negative 6 and our a is 1. So that means negative 6, 2 times 1, which becomes 6 over 2, which is 3. So the axis of symmetry is x equals 3. The vertex we're going to find by plugging 3 back into the equation. So if we plug 3 back into the equation, we're going to get 3 squared minus 6 times 3 plus 5, which then becomes 9 minus 18 plus 5, right? So 9 minus 18 plus 5. 9 minus 18 is negative 9. Negative 9 plus 5 is negative 4. That's our y value. So it's going to be 3, negative 4. And we know it's concave up because our a value is positive 1. So now we're ready to graph. Our zeros are at 1 and 5. Our y-intercept is at 5 as well. Our axis of symmetry is at x equals 3. And our vertex is at 3, negative 4. So I'm going to quickly reflect the y-intercept across the axis of symmetry. So notice how it's 3 away. I'm going to go 3 to the right. And that's just something that you can use from reflections that you learned last year in 9th grade to sort of make sure the parabola looks nice and even. Gives you another point, connect them, and that is what your parabola should look like.